Hi, this video we're going to look at example of a moment in 3 dimension. In the previous video, we're talking about moment is going to be equal to position vector cross F, and this position vector is going to be from the rotational point to any point, right? It's from rotational point to any point on the force, on the line of the force. And so here's our results, our answer. Hopefully we'll get a correct answer. Now let's take a look of this problem. There's a rectangular plate is supported by the brackets A and B and by a wire CD. Knowing the tension in the wire, so the only tension in the wire is going to be CD, right? Is 200 Newton. So they give us the magnitude of force. Determine the moment about A. So it's rotating about A. That we know it's about A of this force exerted by the wire at C. So that tells us it's going to be from C to D. And this is going to be the tension, the force tension from C to D. So there's a lot to read by the statement that tells us it's moment about A, so that's a rotational point, and it's the tension is CD or DC, but here they said exerted by this at C, so we are knowing it's from T, it's going from C to D, so TCD, okay? Because it's exerted, so this is this force point of application is at C, right? So it's a C to D. All right, so knowing that, being able to, first of all, I'm going to say, being able to write this correctly will help you set up in the right pathway. You know the rotational point, you know the force and what direction of this force is from C to D. So in order to solve this problem, we're going to use this R cross F. So R, again, it's from rotational point. For our situation, it's A. So it's from this A to any point on this force. This is CD. So where do we can touch? We can touch C. That's easy. Or we can touch D. D is right there, right? This is D. Or you can do randomly any point on the force. Of course, random is going to be easy. It's going to be difficult because we don't know those coordinates are. So potentially you can use AC. That's your R1 position vector. Then cross product this F. And this F is TCD. So I'm just going to copy down what we have over here on the subscript. Okay. I want you to use that in the future so you know what force it is. Or I can say this is also equal to AD because that's from rotational point to A to any point on the force. D is on there. Then cross product this force TCD. And today we're going to try both and we should get the same answer as you have proved it in the previous video. But here we're actually going to use a number to support our verification here. So now let's first look at it. No matter what, we need to find our TCD, right? We need to write down this force in a vector form. And so this basically goes back to our old topic called force along a line, right? So we can write this force in IJK term. Force along line, the quick summary is going to be the force magnitude without hat times this position vector CD over CD, the distance. All right, so now let's take a look our TCD. Our TCD, do we know the magnitude? We do. It's 200 Newton, the tension. And then we're going to read CD position vector. And for this problem, they didn't tell us the coordinate, right? So in that situation, you're going to make your own coordinate. So when we make our own coordinate, you can just randomly say, okay, it's arbitrary. It won't affect your answer. You're going to get the same answer at the very end. So if that's x coordinate, this is y coordinate, this is going to be our z coordinate. So knowing that, we can either read out their individual coordinate, or you can figure out their relative coordinate difference. So let's read out C coordinate. The x coordinate is going to be 300. And y coordinate is 0 because it's on the xz plane. The k coordinate is going to be all those together, right? Because it's going to be 80 plus 240 plus 80, all those three together. So that's going to be 160 plus 240. That's going to give us 400. Okay. All right. Now let's look at the D. D is on YZ plane, so x coordinate would be 0. And how tall is it? What is y coordinates? This 240, right? And how about Z? It's at a positive Z direction, but how much forward? It's this 80. So we have that figured out. Then CD position vector, it's going to be final point minus initial, D minus C. So it's going to be negative 300 because it's 0 minus 300 for I. And our J is going to be 240 minus 0, so it's plus 240J. Then K, it's 80 minus 400. So that's going to give us negative 320. Okay. Then the rest, we're just going to figure out the distance from C to D. So using Pythagorean theorem twice, we should be able to get the distance between them. Let's pause, see what we have. So the answer I have here is 500. So we get 500, and then we can go ahead and simplify it. Look at the I term. So we have 200 times negative 300 divided by 5, right? So we will have negative 6 over 5, which is 1.2. I'll make it a little bit closer. So negative 1.2i. Now let's look at J term. J term is going to be 200. So put in your calculator. 200 times 240, then divide by 500. Then, oh, this one is not 1.2. This one is going to be 120, right? Yeah, 120. Then the second term for the J, what I have is 96J. Now let's look at K term. K term will have 200 times 320, then divided by 500. And it's a negative value, so it's negative 128K. Alright, so that's what I have for TCD, this force along a line. Now, next step is we're going to solve this position vector if we were using AC, right? If you were using AC, you're just going to read the position vector. Here you already read the C coordinate, and then we just need to go ahead and read A coordinate. So let's write it down here. A is on Z axis, so X and Y both going to be 0. And the Z coordinate for A is going to be 240 plus 80. So that's going to be 320 here. So in that situation, AC, using C minus A, final minus initial, we'll have 300I. And J, 0 minus 0, so it's nothing. And K, 400 minus 320, we'll get 80K, right? Or some of you might decide to choose position vector as AD. If that's the situation, use D minus A. Let's go ahead and get that also. 0 minus 0, it's I, so 0I. J, 240 minus 0, 240J. And K, 80 minus 320, so you will get negative 240K. All right, so you get totally different position vector. As you can see, AC and AD are different. But magic happens when you start to do cross product, which was our next step. What we're solving is this tension, TCD, applied at point C, rotating about A. If we were using AC as our position vector and then time cross product this force in a vector form, so our AC is 300I plus 80K. Then cross product, our TCD, negative 120I plus 96J minus 128K. All right, you can go ahead, use many different ways to solve this. You can use IJK circle, and you can also use a matrix. Also, you have used probably your calculator or online Wolfram. Let's go ahead and try that. So here we are going to use Wolfram Alpha calculator online. So remember those 8 vector forms: 300, 0, 80, negative 120, 96, and negative 128. So we're going to put it in right here. Let me see. What I'm going to do is I'm going to take a picture of this and then go to this online. So what I have here is negative, it's 300, comma, 0, 80. Then the next one is going to be negative 120. Then 96 and negative 128. So we go ahead and submit. We should have our answer for this cross product, and that's our answer in right here. As you can see, it's going to have I term, J term, and K term, which is what we expect because this is moment. Moment in 3D is going to have a direction. And let's go ahead put into our notebook here. So bring this answer in. I have negative 7680 for I term, and the J term is 28800J term, and our K term is 28800K term as well. So now what I'm going to do is, if you happen to use a different position vector, and if you have using AD, we're going to see if we're going to get the same results, right? So AD is going to be this, 240J minus 240K. Then we're going to cross the same force, negative 120I plus 96J minus 128K. All right, so now let's go ahead, get into our calculator here. So it's a 0, 240, and a negative 240 for this position vector. Is that right? Yeah, 0, 240, and negative 240. And we have the same force along the line, same force. Let's sum it. And guess what? We have the same answer as you expected. We got same one, negative 2680I plus 28800J plus 28800K. So you solve this problem. They ask you the moment about A of the force exerted at C, and you have an answer. That's going to be the moment. Now let's look at this one. This I term, which means this moment about X direction. And this J term tells us this M rotating about Y axis. This is moment about Z axis. If you want to find the moment all together, you can use Pythagorean theorem to solve them all. Okay, So for example, if you want to find m, magnitude is going to be 7680 plus 2880 square plus 28800 square. Then you get your magnitude. And the unit for this will be our Newton millimeter. That's it. Alright, hopefully you enjoy this one. Moment about point in 3-dimensional using RxF. See you next time. Bye.